How's it going, guys? We have another redox problem here. This is the third acidic problem, and it's a little bit more challenging than the last, but I think after doing the last two it shouldn't be too bad. So let's jump right in. So step one. This is listing out the charges. Again, this is not necessary for everyone, but I think it's a helpful step whether or not it's required, as long as you have time. You know, if you're on an exam and you're gonna worried about running out of time, I wouldn't worry about it if it's not required. But so here we have no charge. We can assume that this sulfur is a 2- because each H+ we know is a 1+, and there's two of them and it has no net charge. Same thing with the O. We can see the O is going to have a 2- per oxygen molecule. There's three of them there, so 3 times 2 is -6, and then if it has a negative net charge of -1, that N must be +5. So now on this side, that sulfur is alone. We can just assume that's a 0. You know, there's nothing written there. And with this, it's going to be the same. Assume it's a 2- and a +2 on that nitrogen. Alright, so moving on. Step 2, we're going to split this up. So we can start out with H2S yields S8, and NO3- yields NO. So far so good. Now on 3 we're going to balance the non-H and O's. So first off, we have this H2S on the top, goes to the S8. That's a big problem. We have 8 sulfur over here and only 1 over here. So we're going to have to multiply that whole thing by 8. End up getting 16 hydrogens. So we'll worry about that later. Now we have NO3 here and NO over here. That's all set for now, until the next step. Okay, now we're going to need to balance our O's with water. So we'll start off with this top one. H2S yields S8. There's no O's, so we're good to go. Now we have NO3- yields NO. We have 3 O's here, only 1 O here. Gonna have to add 2 waters, because each water only has 1 oxygen molecule, or element, yeah. So we have 3 over here, 3 over here, good to go. On to step 5. Balance the hydrogen out using the hydrogen ions. So I'll start with the top one again. We have, like I said, 8 times 2 is 16 hydrogen over here. So we're going to have to add 16 hydrogen over here. On the bottom now we're going to have, let's see, 2 times 2 is 4 hydrogen. So we can just throw that 4 right there. 4H plus NO3- yields NO plus 2H2O. Alright, not so bad. So now we're on to step 6. We balanced our H's, we balanced our O's. Now we're going to balance our charges. Okay, so first off we have, I'm just going to space down the 8 H2S S8 plus 16 hydrogens. So it looks like there's no net charge over here based on what we had been given at the top. There's no net charge, so we can assume that this is 0. And this is positive 16 because that S8 has no charge, and this obviously is an ion. It's a cation. So we're going to just add on there 16 electrons. Now on the next one we have 4H plus NO3 minus yields NO plus 2H2O. There we go. So now we have, let's see here, a net charge of -1 here, +4 here, so we've got +3 on one side. And then on this side we have nothing here and nothing here. So it looks like we might have to add 3 electrons to this side. Let's see here. Okay, so now we got a problem. I'm sorry, that should have gone on this side. 3E minus, there we go. Cool. That was an even bigger problem. Now we have another problem. We have 16 electrons on this side, on the product side, and on the reactant side we only have 3. So we're going to have to find the least common multiple, but obviously there's nothing easy with these two. We're going to have to just do 3 times 16 and 16 times 3 to get it all sorted out in step 7. So yeah, step 7, set the electrons equal. Start off with this top one. 8H2S yields S8 plus 16 hydrogen ions plus 16 electrons, and this whole thing we're going to have to multiply by 3. I always draw this arrow like I said in the last video because time and time again that if I don't do that, something wrong, something happens. Maybe I'm being superstitious. Okay, so what do we have here? 24 H2S yields 3S8 plus, is that 42? Nope, 48. H plus 48 electrons. Nice, looks good. Now we have to multiply the other formula, this one, by 16. So we have 3 electrons plus 4 hydrogen ions plus NO3 minus yields NO plus 2H2. Oops. Oh. Okay, now multiply this whole thing by 16. And we're going to end up with, let's see here, 16, I'm sorry, what am I doing? 16 times 3 is, again, that is 48, so we're going to have 48 electrons to balance that out, plus 64 hydrogen ions, plus 16 NO3 minus yields 16 NO plus 32 H2O. So we got some big numbers here, but I wouldn't get too nervous because usually things will reduce out pretty well. And in this case, we're going to move right on to step 8, and we're going to combine and reduce. Okay, so let's see. Again, this is kind of there's a lot of numbers, a lot of letters here. Take it slow if you have the option to, because I'm very prone to make mistakes. So here we go. 24 H2S plus 48 electrons plus 64 hydrogen ions plus 16 NO3 minus yields. Start off with this one. What was that? 3s8. Okay. 3s8 plus the 48 hydrogen ions plus the 48 electrons plus 16NO plus 32 H2O. Okay, so that's a mouthful. But first off, really easy, we can just get rid of those electrons. That's why we did that multiplication before. Now we have 16 hydrogen over here, 64 over here and 48 over here. Divide both sides by 48. Subtract out 48 from both sides. So that'll cancel this out. And then down to 16 hydrogen ions over here. And then the 24 H2S. Kind of just fill in the rest of the equation after reducing that down. And then we have the 3S8. That S keeps looking like a 5. And then these have both been canceled. We have plus 16NO plus 32 H2O. Looks like there's a lot of common multiples here. You could divide it out, but it's not going to work because we have the 3S8, and it's just easier to keep it this way. There's no other way that I can find to reduce it down further from here. So yeah, hopefully this helps someone. And back to that mnemonic, that'll be helpful. Have no fear of ice cold beer. That's all the diatomics. Okay, and yeah, you have the electrons here. Just remember, if it's on the reactant side, it's probably reduced, and if it's on the product side, it's probably oxidized. And I think that works out the case here. Yep. Cool. All right.